Today we are going to learn about the R equation. In the last class we saw how to construct the Schrodinger wave equation for the hydrogen atom and how to separate the variables, and we had three equations: the P equation, F equation and R equation. We saw already these three equations in the last video, and we already know the solution of the F equation and the P equation. We already discussed this in the last video, and we already discussed this solution of these two equations while we were learning the particle on a sphere. So what we are going to do now is that we are going to the solution of the R equation. The R equation is okay, the R equation is d square R divided by dr square plus 2 by R dr divided by dr plus 8 pi square m divided by h square into z e square divided by 4 pi epsilon 0 r plus e minus beta by r square into r is equal to 0, where beta is equal to L into L plus 1. So we had this equation in the last class itself, but we didn't go for the solution of this equation. So now we start our journey for the solution of this equation. This solution is not as simple as the solution of the other two equations. It is a bit lengthy, but it is not so tough. So let's begin. I'm going to expand this equation further. Then we can write d square r divided by dr square plus 2 by r dr by dr plus 8 pi square m e by h square. What I did is that I multiplied this with this one, okay, with the e, 8 pi square m e by h square plus 8 pi square m z e square divided by 4 pi epsilon 0 r h square. I multiplied with this term, okay, minus beta by r square. Beta is nothing but L into L plus 1 divided by r square all into r is equal to 0. That is our expanded equation. And we have to simplify this equation for the solution. For the purpose of simplification, we are going to make some assumptions, or we are going to make some important substitutions. So when I am doing the solution of this equation, or whenever I am working out this equation, whenever I see that there is a term like minus 2 pi square m z square e raised to 4 divided by 4 pi epsilon 0 square h square e. If I find a term like this, whenever I am when I am working out this equation, when I am expanding this equation, and if I see that these terms comes together like this, then I will call this together as n square. So n square is equal to minus 2 pi square m z square e raised to 4 divided by 4 pi epsilon 0 square h square e. You can see that this almost all the parameters inside this term are constants. Pi, m, z, e, epsilon 0, h, all are constants. But the only one thing which is not a constant or which can vary is the energy. Energy is the only one thing that can be varied. So n square or n depends upon the energy of the electron. Okay, so this is an important substitution. This substitution will make this equation much more simpler. And this is actually not a mere substitution. There is a logic behind the substitution also. The logic is that you know that when you are studying the Bohr model of atom, from the Bohr's assumption you can prove that the energy of the electron in the nth orbit E is equal to minus m z square e raised to 4 divided by 8 epsilon 0 square n square h square. That is the energy of the electron in the nth orbit. Here n represent the number of the orbit, or actually n is a quantum number, because the n can have the values like 1, 2, 3, 4, etc. These are the only possible values of n when we are considering the Bohr model. Okay, so actually in Bohr model, this n is a principal quantum number. It can have only restricted values, and you can rearrange this equation. For example, then you can write like E is equal to, what I am going to do is that I can just multiply this equation with the 2 pi square. Then I will get minus 2 pi square. I multiplied this numerator with the 2 pi square, then I will multiply the denominator also with the 2 pi square, so that the value of this one doesn't change. So minus 2 pi square m z square e raised to 4 divided by, I will multiply with the 2 pi square in the denominator also. When I am multiplying with the 2 pi square in the denominator, I will get 2 into 8, that is 16 pi square epsilon 0 square n square h square. Okay, so then I can simplify this again further, like minus 2 pi square m z square e raised to 4 divided by 16 pi square epsilon 0 square. How can I write this? 16 pi square epsilon 0 square, I can write it like 4 pi epsilon 0 the whole square, right? N square h square, and from this one I can write n square is equal to minus 2 pi square m z square e raised to 4 divided by 4 pi epsilon 0 square h square e, right? So this n square, actually this n square, this one I got from the Bohr model, but you have to remember that in the Bohr model n is a quantum number. It can have these restricted values. So I have taken the same set of parameters here also, right? Minus 2 pi square m z square e raised to 4 divided by 4 pi epsilon 0 square h square e. Whatever parameters are appearing for the expansion of n square in the Bohr model, I have taken the same set of parameters here also, and I call this as n square here itself. But there is a danger, of understanding. See, in the case of the Bohr model, n is a quantum number, as I already said, but you cannot say here that in this case, where we are solving the Schrödinger equation in our case, or the R equation in our case, you cannot simply claim that n will be a quantum number like this. You have no proof that n can have only 1, 2, 3, 4 values here in this case. Here, this is true because this is Bohr model. This is a totally different case. I just took that case to show that these parameters and these parameters are same, but you should be very careful that in the case of Bohr model, the n can have only restricted values, but you have no justification to say that n have only restricted values in this case, because we haven't proved that, right? we have only introduced n. We don't know what are the values of n. Perhaps n can have the fractional values, perhaps n can have the negative values, we don't know. We just introduced the n here and we don't know what are the values. So whenever you are introducing this n square here, you should not confuse that we have just introduced the n which was appearing in the Bohr model. It is not. In the case of the Bohr model, you know what is n. That is a principal quantum number having the restricted values. But here we don't know. Maybe it is the same n as that you will see in the case of Bohr model, but we don't know at this moment what is the nature of n. We will prove what is the value, what's the nature of n in later on. Okay, at this moment we know only that n is something that is defined as the square of which is minus 2 pi square mz square e raised to 4 divided by 4 pi epsilon 0 square h square e. So that is that's the thing. You have to be very careful and you should not misunderstand that case. Okay, and the next important substitution is that whenever I see the set of parameters like 8 pi square m z r e square divided by 4 pi epsilon 0 n h square. Whenever I see this set of parameters 8 pi square m is at r e square divided by 4 pi epsilon 0 n h square, I will call this as rho. Okay, just like I made a substitution for this set of parameters as n square, I will take this set of parameters together. I will call this set as a rho. Okay, so this is rho, and again we can simplify this rho based on our understanding, like some other understanding from the Bohr model itself. I will say how it is to be simplified. So this one I can write like 2 into 4 pi square m e square into zr, right, divided by 4 pi n into 4 pi epsilon 0 4 pi epsilon 0 epsilon 0 h square into n. Okay, I can write like that. Why I wrote like this? Because these set of parameters means 4 pi square m e square divided by 4 pi epsilon 0 h square. Okay, these together, do you know what is that? Okay, I will explain what is that. We will see. And you have learned while you were learning the Bohr model that the radius of the nth orbit r is equal to epsilon 0 n square h square divided by pi m e square. You have learned this already by learning the Bohr model. If you don't know, you can go to a video that I have uploaded in YouTube in the channel Chemistry Nowadays. There is a video on the Bohr model. There you can see all this stuff. Okay, it's this stuff in detail. So you can go there and learn how to derive the energy expression and how to derive the expression for the radius and all these things. There you can see that the radius of the nth orbit r is equal to epsilon 0 n square h square divided by pi m e square. And n represent the principal quantum number, or it is the number of orbit. If it is the first orbit, okay, Bohr's first orbit, then n is equal to 1. For first orbit, n is equal to 1. Then if it is the first orbit, let me call the radius of the first orbit as a0. A0 just represents that is the lowest possible radius. Okay, radius of the first orbit is the lowest possible radius in the Bohr model. So a0 is equal to epsilon 0 n square in that case is 1 square, so epsilon 0 h square divided by pi m e square. I can write it like I just multiply this with 4 pi in the numerator and also in the denominator. Okay, I multiply numerator and denominator with the 4 pi so that the value doesn't change. Then I can write like 4 pi epsilon 0 h square divided by 4 pi into pi, that is 4 pi square m e square. Okay, so you can see 4 pi epsilon 0 h square divided by 4 pi m e square, that is equal to a0, that is the radius of the first Bohr orbit. This is the same thing you can see here. That is the reciprocal of this one is here, that is 4 pi square m e square divided by 4 pi epsilon 0 h square, that is the reciprocal of this one, right? So the reciprocal of this one is 1 by a0, so I can substitute 1 by a0 instead of this. So I can write it rho is equal to 2 zr divided by na0. So I just put 1 by a0 instead of this one. So rho is equal to 2 zr divided by na0. So these are two important substitutions. N square is equal to minus 2 pi square m z square e raised to 4 divided by 4 pi epsilon 0 the whole square h square e, and rho is equal to 2 zr divided by na0. These are two important substitutions that we are going to impose in this equation, okay, when expanding this equation. Since we have these things in our hand, we can start substitutions. Before that, we have to find out the value, or we have to expand some more parameters which are appearing in these equations. First, let us take dr by dr. We have dr by dr here, right? dr by dr. So dr by dr is equal to dr by d rho into d rho divided by dr, right? dr by dr is equal to dr by d rho into d rho by dr. So that is equal to d rho by dr. What is d rho by dr? D rho is equal to 2zr by na0. Therefore d rho by dr is equal to 2z divided by na0, 2z divided by na0. What is remaining is dr by d rho. Okay, so dr by dr is equal to 2z by na0 dr by d rho. Next we can find out d square r by dr square, because we have d square r by dr square here. So d square r divided by dr square is equal to d by dr of dr by dr. So I can write it like d by d rho of dr by dr into d rho by dr. You can write like this, right? So that is equal to d by d rho of dr by dr. dr by dr is equal to 2z divided by na0, 2z by na0 into dr by d rho into d rho by dr. d rho by dr is equal to 2z by na0, 2z divided by na0. So we can write that is equal to 2z divided by na0 the whole square, 2z by na0 the whole square, this one and this one multiplied together, okay, into d square r by d rho square, d square r divided by d rho square. So d square r by dr square is equal to 2z by na0 the whole square, d square r by d rho square. So we have dr by dr, d square r by dr square, Next we need 8 pi square me by h square. We are going to find out the value of this one, 8 pi square me by h square. So 8, oh, I have a lot of dots here. The ink came from this page to this page, right? But it is wonderful, looks nice. Okay, anyway, we are going to find out the value of 8 pi square me by h square. 8 pi square m e divided by h square. That is equal to 8 pi square m by h square, and I am going to substitute the value of e. What is the value of e? We can get the value of e from here. That is, the e is equal to minus e is equal to minus 2 pi square m z square e raised to 4 divided by 4 pi epsilon 0 square h square n square. I am going to substitute this one there. So that is equal to minus 2 pi square m z square e raised to 4 divided by n square h square h square into 4 pi epsilon 0 the whole square. Okay, I just substitute the value e from here. So the n square came here and e went there. Okay, so when we are simplifying this one, I can write 16, 8 into 2, 16 pi raised to 4 m square, m into m square, z square e raised to 4 divided by n square h square into h square, that is h raised to 4 and into 4 pi epsilon 0 the whole square. That is equal to I can again simplify this just by multiplying 4 with the numerator and denominator. When I am multiplying 4 with the numerator, I get 64 pi raised to 4 m square z square. Okay, we have a minus sign here, minus, because a minus sign was here. Minus 64 pi raised to 4 m square z square e raised to 4 divided by again we have to multiply the denominator also with the 4. So 4 n square h raised to 4 pi epsilon 0 the whole square. Okay, so that is equal to minus 1 by 4 into I can write 64 is nothing but 8 square. Pi raised to 4 is nothing but pi square the whole square, m square z square e square the whole square divided by n square h square n square h square the whole square 4 pi epsilon 0 the whole square. So that is equal to minus 1 by 4 into what is that, 8 square. This is every term is a square, that is the square of 8 pi square m z e raised e square divided by n square h square 4 pi epsilon 0. What is that? That is, you can find here what is that. See, it is 2z divided by na0. You can see it here. 2 is because 2zr by na0 is equal to, you can see, I will write it here, 2zr divided by na0 is equal to 2zr by na0 is equal to rho, and rho is equal to 8 pi square m z r e square, 8 pi square m z r e square divided by 4 pi epsilon 0 n h square, right? We have already written this here. Rho is equal to this one. So you can see that actually this is like 8, you can write like 8 pi square m z e square divided by n h square 4 pi epsilon 0 the whole square. Okay, so what is that? Well, it is appearing here except r, that is appearing here. So this term is 2z divided by na0, because see, you can see that 8 pi square m z e square by 4 pi epsilon 0 n h square is this one except r. See, so if you are striking out r from this one, what we get is 2z by na0. So this is 2z by na0, that is minus 1 by 4 into 2z divided by na0, 2z by na0, the whole square, 2z by na0 the whole square. So we have the expression for 8 pi square m e by h square. Next, what we are going to do is that I am going to take the next term, that is 8 pi square m is a d square divided by 4 pi epsilon 0 r h square. This term I am going to simplify. 8 pi square m, 8 pi square m is a d square divided by 4 pi epsilon 0, 4 pi epsilon 0 r h square, or h square r, whatever it is, h square r, that is equal to, how can I write this? 8 pi square m, 8 pi square m is that e square, 8 pi square m is a d square into n. I am going to multiply this with n divided by 4 pi epsilon 0, 4 pi epsilon 0. I have to multiply the denominator also with the n, right? H square into n, there is an r also. So what is this? I am again taking my green pen so that I will round a set of parameters that is familiar to you. 8 pi square m z square divided by 4 pi epsilon 0 h square n. Okay, after this you are familiar. 8 pi square m z e square divided by 4 pi epsilon 0 n h square. What is that? This one, right? The same thing what we saw here. 8 pi square m z e square divided by 4 pi epsilon 0 n h square, that is 2z by na0. So again we can write like 2z by na0, that is equal to 2z divided by na0 into n divided by r, into n divided by r. And now I am going to substitute for r. How can I substitute for r? Because we have the equation rho is equal to, we have, I will write here, okay, we have rho is equal to, what is rho? We have already written here, rho is equal to 2zr by na0, 2zr divided by na0. Therefore we have an 1 by r here, 1 by r. Therefore 1 by r, if we can find out 1 by r, we can take this r here. Therefore 1 by r is equal to 2z divided by na0 into rho. So we brought r here and rho here. Okay, it's cross multiplication. So 1 by r is equal to 2z divided by na0 into rho. We can substitute for 1 by r here as 2z by na0 into rho. Then we get this one is equal to 2z divided by na0 into n into 1 by r, that is equal to n into 2z divided by na0 into 1 by rho, right? We have here. So that is equal to 2z divided by na0 the whole square into n divided by rho. So we have this parameter, the simplified parameter as 2z by NS0 the whole square into n by rho. So we have everything here. We have d square r by dr square, dr by dr, we have 8 pi square me by h square, we have 8 pi square m z d square by 4 pi epsilon 0 r h square. We have everything. Now we can substitute for, we know what is r is Na0 rho by 2z, everything we have. So we can substitute these values in this equation. Okay, in this equation we are going to substitute. So after substitution, what we are getting, I am going to write the equation again here. d square r divided by dr square plus 2 by r into dr by dr plus 8 pi square me by h square, 8 pi square me by h square plus 8 pi square m z d square, 8 pi square m z e square divided by 4 pi epsilon 0 r h square, 4 pi epsilon 0 r h square minus l into l plus 1, minus l into l plus 1 divided by r square into r is equal to 0. That's our equation. So I am going to substitute for this one. When I substitute for this one, what we get is d square r by dr square. d square r by dr square is 2z by Na0, 2z divided by Na0 into, what is that? We have here d square r by dr square. d square r by dr square is equal to, where is that? 2z by Na0 the whole square, d square r by d rho square, d square r by d rho square plus 2 by r. So we have to substitute for r also here, 1 by r. We already have 1 by r. 1 by r is equal to 2z by Na0 rho. So we write 2 into 2z by Na0, or we can write 2z by Na0 rho is in the denominator, so I write here. So 2 by rho into 2z by Na0, that is 2 by r into dr by dr. dr by dr is equal to, what is dr by dr? 2z by Na0 into dr by d rho. 2z divided by Na0 into dr by d rho. dr by d rho plus, what is inside the bracket, plus 8 pi square me by h square. 8 pi square me by h square is this one, that is minus 1 by 4, minus 1 by 4 inside the bracket, minus 1 by 4, 2z by Na0 the whole square, 2z by Na0 the whole square, that we have already done here. 2z by Na0 the whole square, that's the first term, and this term, the second term, and second term is equal to this one, 2z by Na0 the whole square into n by rho, that is plus n by rho into 2z by Na0 the whole square, 2z divided by Na0 the whole square. Then what is remaining? Minus L into L plus 1 divided by R square, divided by R square. So we have to take L into L plus 1 into 1 by R square, and 1 by R is equal to 2z by Na0 rho. So we have a rho square in the denominator, rho square, because the rho square comes from here, and what is remaining is 2z divided by Na0 the whole square, 2z divided by Na0 the whole square into r is equal to 0. So we have substituted for all the terms. So what is the common factor in all the terms? You can see that 2z by ns0 the whole square is here. The first term, 2z by ns0 the whole square. These two multiplied together, okay? 2z by ns0 the whole square, 2z by ns0 the whole square, 2z by ns0 the whole square. So 2z by ns0 the whole square is a common factor in all the terms. So we have 2z divided by na0 the whole square as a common factor into what is remaining is d square r divided by d rho square plus 2 by rho into dr by d rho plus 2z by ns0 the whole square. That is gone. What is remaining is inside the bracket minus 1 by 4 plus 2z by ns0 the whole square is gone. What is remaining is n by rho, and here what is remaining is minus l into l plus 1 divided by rho square into r is equal to 0. So we can again write, we can take this, we can cross multiply this na0 the whole square to here, and then 2z the whole square to here. So, or we can just divide the whole equation, the left hand side and the right hand side, with 2z by na0 the whole square. Then we get d square r by d rho square plus 2 by rho dr by d rho plus minus 1 by 4 plus n by rho minus l into l plus 1 by rho square into r is equal to 0. So we have a new equation, and this new equation we have, instead of r we have rho. Okay, so we have simplified this equation. Earlier, you can check what was our equation, previously what was our equation. We have d square r by dr square plus 2 by r into dr by dr plus 8 pi square and by h square and d square by 4 pi epsilon 0 r plus c minus beta by r square into r is equal to 0. And from this equation we have reached another equation. And why we have reached this equation? Because this equation is much easier to solve than this equation, and we will see why it is easier to solve, and I will explain the solution of this equation in the next video. So what we have at this moment is we have a new r equation, and that r equation is in terms of rho, and where rho is defined as 2zr divided by na0. Rho is depending upon r itself. So here we have n, we have introduced n, but still we have not established what is the nature of n. We don't know the nature of n, as I said earlier. So don't confuse that. We already have a quantum number. We will prove whether n is a quantum number or not. At this moment we have n here, and we will establish its nature. Until then you can wait. So we will explain the next things, the further things in the next video.